All right, we are back. I just did this whole broadcast without any audio, so congratulations. It's only my second time casting, so back. That's probably all it is. I got chat up, so if anyone wants to chat, please do so. All right. So, this video here is about scripting inside of Unity, and this is a little bit of a spawning system that I've created using some information that I've learned over the past few years on scripting. And so I'm just going to walk you through how I set it up. Everything's kind of already set up and working, so I just want to be able to get this down so that anyone who's looking for this on YouTube can go ahead and check it out. So without further ado, I've opened up Unity here, and hold on one second. Yeah, okay. Got Unity up here, and I have created these very awesome enemies. They are muscular dudes in underwear, and this is part of the character I was working on from yesterday's ZBrush stream, but this is just these are just little temporary things. I thought this would be more interesting than using cubes or spheres or something, so I made a red, blue, green, and orange enemy, and I gave them some materials here. I put them in here as prefab, so after I set their material type and settings, I went ahead and dragged them over here and made them prefab, so I don't actually need these anymore. You got your main camera, your directional light. As always, you don't need any of this. I made a floor plane so that we could see the ground. And here is where all the magic happens. This is an empty game object with the spawning script on top of it. So we're going to go ahead and open this up so we can see how it works inside of MonoDevelop, and blow the text up so it's easier to see. I think I'm streaming at 720. So in this script, a few things that I'm doing here, I'm using object pooling as opposed to just creating and destroying the enemies. This is done for a couple of reasons, mostly because the game project that I created this in originally is for mobile, and so I wanted everything to be loaded in at the beginning of the game, and not dealing with a lot of garbage collection, which is when objects get deleted and then removed from memory. In this case, you just always have them pooled, and then you're just setting them active or inactive as opposed to destroying and instantiating each time. And one of the things that's important with this script is that you're always using system.collections and Unity Engine, obviously, but in the script we've added using systems.collections.generic. And really what this is allowing me to do is use a function called list so that I can get a list of the game objects. I have a couple variables in which we declare for the script to work. The first one is a private game object enemy spawn. This will just is basically kind of an empty game object that we're going to put information into from this game object, which is a public array of game objects, which allows us over here to set the size of the array and then to populate the array with the objects. I'm going to actually change these values really quickly because I was setting these earlier and making Unity cry. So then we also have a public integer of the maximum number of enemies, which is set to 32. and another public integer that is the maximum enemies in memory, which is 128. And this allows, since there are 4 of them, this allows for there to be 32 of each type in memory, so that if I had some part of the script that said I want all red guys or all orange guys or all blue guys, I would have 32 of those objects available in memory to pull from, because otherwise we would have to create them and add to the memory pool. So this way we're not adjusting the amount of memory being used. This is where collections.generic comes in. So we're getting a list of type game objects, and we're going to set that to enemies so that we can call it later. And public static integer. The reason that the number of enemies is a public static integer, it doesn't have to be in this case, not for this demonstration, but I set it to static because I wanted to be able to access it from other scripts in the game, other reasons why the number of enemies would be changed through a different script. Then we get some values here for the spawn range and the minimum spawn range. And these are also just integers. They could be floats if you wanted them to be, but I didn't need them to be. I didn't need them to be that variable, so I just left them as integers. And then we get another private integer, which is called enemy switch, and this is, here wants me to talk a little louder. Should probably turn up your volume if you can't hear me, because I think I'm on max audio. Let me know if that's Let me check my settings. Oh, that's going to cause it to double up. Maybe this will help. I'll just get a little bit closer to the microphone. Anyways, as I was saying, so the enemy switch integer is actually controlling the case of the switch. So down here in this other function that I've created for game objects is it's a switch statement, and switches change based on cases. And in this case, this is the case value. So if enemy switch up here gets defined as 0, then we will use the default, because switches are much like an array in that they are 0 based, so they start at 0 and not 1. So you start at the default, which is 0, and then progress to 1, 2, and 3. So what's important here is that, so here's the beginning of the script. This is what happens when the game starts, because the game object is already in the world whenever it starts. So call a void start function, and we're going to set the enemy switch to 0. So that's what we were just talking about, where we're going to set this as the default value at the beginning of the game. And what that's going to do is it's going to spawn whatever happens to be in the 0 slot of our array, which here is enemy red, so red is the default. We set the number of enemies to 0 because in this case we're not actually spawning anything yet. All we're doing is creating a list and pooling them into memory. We'll go ahead and get a call that generic collection again here, where we're doing a new list, and these are going to be called enemies. And then we're going to do a simple for loop, and we're just using the standard case for the for loop where the integer I equals 0, and then while the value of I is less than the max enemies in memory, we're going to increase I until we get to that point. So once this finally reaches 32, or sorry, 128, the for loop will stop. But for while this isn't true, this is going to continue to execute and go through the loop. And then in this case, we're setting this game object and giving it a variable name of obj, and the only reason I'm doing that is because I had enemy in every other section. I didn't really know what to call it, so in this case it's just another game object and it's called obj. And it is set to game object instantiate, which is going to create the object. And then what it does is it runs through to find the proper game object to instantiate. It runs through that script. So it comes down here, it says, which one am I supposed to be getting? Oh, well, enemy spawn is enemy type 1, enemy spawn is enemy type 2, and it goes through and does that. So we create it, we instantiate it into our world, and then we set the object to, we set the object's active state to false, so that it's just there. It's not in our, it's in our game, but it's not in our world yet. And then this is just adding it to the list. So we're adding it to here, to the game object list. And this is where we're gonna pick our enemy switch here. So it was set to 0 at the beginning, and then after it's done with the 0 case, we want it to move to the next case over. So each time it's doing this, it's going to add 1. So it'll go from 0 to 1, from 1 to 2, and so forth. And then once, and we do a simple if statement to check whether it gets bigger than 4, and if it does, then we set it back to 1. And like I said in the previous broadcast, I don't really know why it's 1 and not 0. It makes sense for it to be 0 to me, but I guess it's because I'm already setting it to 0 at the start of the script. So that's it. That's what happens at the start. Now the next thing that we do is we do a simple while loop. We just check for the number of enemies to be less than the maximum number of enemies. And our max number of enemies is 32. And while that's true, we're going to spawn enemies, and so for that case, we'll just go down to the next function, the void spawn enemies function. And for this, we need to get a location to place them at, so we do a little bit of vector math. We do vector spawn location, The way we're doing it here is we're using a random.inside_unit sphere and multiplying. So this will give you a vector of 1, 1, and 1, or a range up to 1. It's a normalized sphere that's 1 unit in all directions. And you're going to multiply that times spawn range, which in this case is 100. And I have another function that we'll go over that's a little bit different and yields a similar result. Problem with this is that if we were to just use the inside unit sphere, the characters would spawn around the world in a spherical pattern, so they would be off of our ground plane. So the way that we fix that is simply by getting a new final location and getting a new vector 3, and all I'm doing is getting the x value of our spawn location, setting the y value of this vector 3 to 0, and then getting the z location of our spawn location. And this is a little bit of a gotcha moment in the script that I didn't really think about, but occasionally while calculating these values, it is possible for the value to become infinite. So what I do is I just do a simple if statement to check if the float values of x, y, and Z are infinity. And if this is true for final location, if this is true, then I just found a different vector, the 5, 0, 20, and this is just something that I thought was acceptable location. But then I also wanted to know about it, so I have it print to my console that it fixed the infinity issue, just so I know that it occurred. So here's where we're actually going to create the enemies. This is where it's actually the magic is gonna happen here. So if the number of enemies is less than the maximum number of enemies, simple logic, we're gonna go through another for loop. And we're gonna use the same case for loop that we've used before, where we're gonna say for I equals 0, as long as I is less than enemies.count, and enemies.count is referring back to the game object list that we talked about earlier. We're going to increase the value of I. And then the next thing you have to do is check and see if it's active in hierarchy. We're checking to see if it's active in hierarchy because we want to get something that isn't active. If it was already activated, then there's no point in reactivating it. So the exclamation mark means that this is false. So it is false. If it's false that the enemies sub I are active in inventory, then we're going to give it a location. We're going to give its transform position, the location of final location, which was calculated up above. And we also have to give it a rotation, and its rotation is quaternion.identity, and quaternion.identity is just referencing its local rotation. I could also say, I could also do a local transform local rotation for that object, but in this case it's easier just to use quaternion.identity, and it's simpler. And then here we go, we set it active. And after we set it active, we have to increase the number of enemies so that this won't just run indefinitely. And then we break out of the loop, and we can show you how it works. So go ahead and hit play. And you can see that the red, green, and blue guys have randomly spawned across the map. And over here in the hierarchy, you can see that it has created a list of 128 enemies that can be set active or deactive at your whim. And then the other thing is that it goes red, green, blue, orange, red, green. So it iterated through each one. So I know that I have 32 reds. So if I have some logic in the script that says I just want reds, or I just want blues, or I just want greens, I can do that. I can check very easily for that. And then you can see now here in the scene, as I increase the maximum number of enemies, they're going to start to populate. So you can see it, and I can't reduce the value obviously because there's no logic for setting them inactive. You'd have to have a script for killing them, or click on them and set them inactive or something. I don't have that script written out, so it's not a part of this tutorial. We can increase the number. So if we knew we had exactly 512 enemies, then we could set this to 128. And we could hit play. Boom, and Unity starts to choke because this model isn't it's kind of high res. It's not super high res, but yeah. So there's 128 different guys. Cool. Well, that pretty much does it for this video. This will be added to YouTube now that the audio worked, and people that want to see the script up close and copy it or whatever can do that without any issue. So thanks for tuning in, and hope you enjoyed the content. I might start doing these as just local YouTube videos that I'll just upload to YouTube, because I'm not so sure that people on Twitch really care about this. But if you're interested, subscribe, and thanks again for stopping by.